Hello guys, welcome to the problem of the day series where we are going to solve LeetCode and GFG problem of the day of day 18. So proceeding to the problem of the day, so the first will be of LeetCode and which is minimum number of arrows to burst balloons. The problem statement is there are some spherical balloons taped onto a flat wall that represent the XY plane. The balloons are represented 2D plane integer array points where points of I equal to x start and x end which denotes a horizontal diameter which traces from x start and x end. Now the arrows can be shot off directly vertically in the positive y direction from different points along the x-axis. Now the main point is a balloon x start and x end is burst by an arrow shot at x if x start is lesser than or equal to x and x is lesser than or equal to x end. So this will be our main thing to note down. There is no limit to the number of arrows that can be shot. So there will be no limit. A short arrow keeps traveling up infinitely. Now, given the points, return a minimum number of arrows that must be shot to burst all balloons. So this is such a big problem statement. To summarize it up, we will given a points array, which represents a balloon width, and these points array are on the x-axis, consider x-axis, and we have to select a number of x, which sorts up the maximum number of balloons of which overlap along the width. Now, I will highly recommend you all to solve the uh, yesterday's, no, sorry, the 17th day 17 problem of the day of lead code, which is merge intervals. So it will give a basic idea of how this interval type of problem works. So continuing with this problem, so the example one, the points are these are the given points. The this thing represent x coordinate and x start and x end, and this is the width of a balloon. The output is 2. Now the output is 2 is because we can select. I will. So this is the example. Now the as an explanation, it says shoot an array x equal to 6, then burst the balloon 2, 8, and 1, 6, and shoot an array at x equal to 11, bursting the balloon 10, 16, and 7, 12. Now this is the x coordinate. Now don't consider the y coordinate axis because the x coordinate gives a pretty much overview of what we have to do. And this is the plotted line are the balloon width. So the first balloon is uh, between 1 and 6. This is interpolated at 1 and 6. Now the second is at 2 and 8, 2 and 8. So these are all the balloon widths. Now we have to greedily select a certain point which makes the maximum number of balloon burst. So in this case, what we can do is we can we can choose this 6, which this 6 will burst up 2 balloon in this way. And the other point I greedily that we could select is balloon number 11, which burst up this 2 balloons. So the maximum result will be of 2. Now, this problem is a greedy approach as we have to select the number which could burst the maximum number of bullets. You might also think this as a DB problem, but given the constraint, we could not think of it as a DB problem because the x start and x and the coordinates will be between minus 2 raised to 31 and 2 raised to 31 minus 1. So, as it is not a DB problem that we will choose another method, so it is a greedy problem. We can think of the scenario. So what we have to do is, yeah, as usually we encounter this kind of problem, we have a merge of this interval or overlapping interval. What we have to do first, we have to sort the list. So sorting the list in this scenario, the sorting the list based on the end value, it will be more beneficial. So think about it. If we select, so given a balloon of width 1 and 6, we have to select the last coordinate of the balloon. The so in this, the last coordinate of this, so last width of this balloon is 6. So as we can choose the 6, we know that 6 will be a particular point which will burst this particular balloon. Definitely will burst this particular balloon. So Choosing the last point will also make sure that it can burst up other of the balloons, which can overlap. So this is the intuition behind it. We have to choose the given a balloon. We have to choose its last coordinate so that it can cover a maximum number of balloons at that balloon also, because six is between 1 and 6 in a given condition. So this will be our intuition in this problem. So sorting this list in the basis of n coordinate will give us 1 6, as you can see. It will be in the form of this, and now it is 1 6 10 2 8 7 12 and 10 16. So the steps of this problem will be we will choose a current point. The current point is our point that we are choosing currently to burst up balloon. So we have choose the current point as 6, and we have updated our result as 1. Now after that a for loop will run from 1 to n, that will cover up all the coordinates or the balloon bits. So in the step 1 we will check if 6 is lesser than 1. No, 6 is not lesser than 1. So it will not go in the if condition. I will later on tell what the if condition is. Now, in the step 2, is 6 lesser than 2? No, 6 is not lesser than 2. So, and in the third step, is 6 lesser than 7? Yes, 6 is lesser than 7. So, 6 will not be in between 7 and 12. So, we have to update. So, it will be in the if condition, and we will update our current point to 12 and our result to 2. So because we are choosing the second coordinate to burst of a balloon that might overlap between 7 and 12. In the fourth condition, it will check if 12 is lesser than 10. So this will be our end of our for loop, and we have successfully uh, burst up all the balloons that are overlapping with minimum arrows. So this is all for this problem, the explanation part of this problem. So the code is pretty straightforward if you found out the intuition between this problem. So the arrays, we are sorting the array on the basis of the end value. We are using the integer but compare, not just a simple lambda function, because if you do something like this, wait a minute, it will get copied. If you do something like this, as a given constraint are between 2 raised to minus 2 raised to 31, so minus minus will become a plus, and it will not give result in proper order. So in scenarios like where we have negative values, we have to use this function integer compare. Now we are updating the result and the current point to point of 0 1. There is a for loop which is iterating. If the current point is less than point of I0, then we update our current point to the second coordinate below, or the last or the last point or the last width of the balloon, and we will be updating our result and we will return our result. This way we can achieve our goal of uh, bursting the maximum balloon with minimum number of arrows. So now proceeding to our second problem, or the GFG problem of the day, of day 17. So the problem statement is the problem is a level order traversal. It's just an algorithm that we have to code. So given root of the tree with n nodes, find its level order traversal. Now, level order traversal of a tree is we have to go in the tree in this way. Then we will the first our 10 is in the output, then 20 and 30 will be in our output, then 40 and 60 will be in our output. So this is our level order traversal. So we can achieve this level order traversal using a queue. So what we will do is in this we will store our root node in our queue. Don't consider as a 10. We will store our root node. So I am just writing it to simplify the explanation. So in this queue, we will store our root node. Then we will have a while loop which will run until queue is not empty. So we will remove our root node and we will check if its right and left value are not well are not null or not. If any of in this scenario, the left node and right node of 10 are not null. So in this queue, we will add 20 and 30. Then after that, we will remove 20 and add its value to result and check if its left and right values are not null and add it to the queue. So the 20 left and right node are 40 and 60. So after 30, you can see 40 and 60 are added. Now we will remove the 30 node and add it to the result and check if its left and right value are not null and add it to the queue. So you can see that 40 and 60 they don't you can see that 30 don't have any left and right node. They basically both are null, so nothing is added. Then we remove 40 and do the same process, and then we will remove 60 and add it to result. And now in this case our queue is empty, so we will loop out of we will break out of our while loop. So in this case, we can print all of the root node and can perform level order traversal of a tree. So our code is pretty straightforward. We initialize a queue. So it is particularly in Java, the array queue we can use, and we can add the root node of the tree. And we are initializing an array list for storing the result. Now we will run a while loop until queue is not empty. So we will remove our first node, add it to result, and check if it's left node or and the right node is not null. And similarly, we will add its left node and right node to the queue. And after the whole while loop is over, we return our result. So guys, this is it for the day. I hope you did understand and the explanation and the code part. So let's meet tomorrow with a new problem and new challenges. That's all for the day. Thank you.